Hello everybody, my name is Saurabh Panse and in today's video we are going to learn about how to increase and decrease the brightness of the LED, which means how to fade our LED, which means how to use our LED in the analog way. So on the screen, as you can see that we have connected our LED to pin number 11 of the Arduino board. So you might wonder why I have connected this LED to digital pin of an Arduino when we have to make use of the LED in the analog way. So why we have not connected it to the analog pins of the Arduino? Yeah. So the reason for it is analog pins of Arduino have an inbuilt analog to digital converter. So what does this analog to digital converter do? It converts the analog signal, the analog input or the analog values that we give in the Arduino programming language in the digital way, and it gives the command to the LED in digital form. So the LED works in the digital form. So this is not what we want. Then how can we make use of LED in the analog way? So Arduino provides you with the solution. There are special kind of pins in the Arduino which we call as PWM pins. So so as you can see here, in the digital side of the Arduino board, you can see here a PWM which is represented by a symbol, a sine wave or a symbol of a wave. So the pins having these wave symbol are the PWM pins, and on connecting our LED to these kind of pins, the pins from 11, 10, 9, 6, 5, 3, any from these pins, when we connect our LED, we would be able to make our LED to work in analog way. So now let's see how to program this. So on clicking on the code and on selecting the text, the coding area appears, and this is the code of a simple blink program of an LED. So by this program the LED will work in the digital way. So we have to make our LED to work in the analog way. So what we will do, we will convert this digital write function or digital write statement to analog write statement, and we will write here some value. Okay, so let's change it from digital to analog, and I will write your value, and we have to change the pin number as well, as I have connected it to pin number 11 and not 13. So we will first change the pin number from pin number 13 to pin number 11. And we will change the digital write function to analog write function, as we want to make the LED to work in the analog way. Okay, so I have changed this. Now the question arises on what value to write here. Okay, so usually we write 1023 value, and for low we write 0. So where does this value comes from, and what does this value actually means, and does pin number 11 accepts this 1023 value? So let's see. So this is the whiteboard. Okay, and I will explain you in detail about what this 1023 represents and where this 1023 comes from. Okay, so this 1023 is an analog value. Actually it is a range starting from 0 to 1023. What does this mean? This means that we can get the values in between this range. We can add any values and we can get the desired output. So here 0 stands for 0 volts and 1023 stands for 5 volts. So when we give the value of 1023, the Arduino will supply 5 volts, and when we will give the value of 0, the Arduino will give 0 volts. So where this 1023 number comes from? Okay. So if we see, then 1023 comes from the formula 2 raised to n minus 1, where n is equal to resolution of the pin. So in our case, the resolution analog pin is 10 bit. So analog pin, it has a 10 bit resolution. So here n would be 10. N would be 10. And when n would be 10, then on substituting the value of n in this formula, we will get the value as 2 raised to 10 minus 1, which gives you 1023. And 1023 value starting from 0. Okay, so the range would be 0 to 1023. So this is how we get this value of 1023. But now we have not connected our LED to analog pin of Arduino. We have connected it to digital pin of Arduino, which is a PWM pin. So what is the resolution of this PWM pin? So the resolution of this PWM pin is, again deleting this. So the resolution of the PWM pin is 8 bits. So what range of values can we get? We would get the value ranging from 0 to 2 raised to n minus 1, where n in this case, in the case of PWM pin, is equal to 8. So substituting the value of n as 8 in this formula, we would get the range from 0 to 2 raised to 8 minus 1, 2 raised to 8 minus 1, which is equal to 0 to 255. So on giving the value of 0, you get 0 volt, and on giving the value of 255, you get 5 volts. So Arduino supply 5 volts on giving the value of 255. So as we have connected it to PWM pin, we have to make it clear that PWM pin have the resolution of 8 bits. That's why the range of the value will be from 0 to 255. If we would have connected our LED pin or any other analog component to analog pin, then the resolution of that pin would be 10 bits, and we would get the value ranging from 0 to 1023. Yes, so as this is connected to PWM pin, the value will not be 1023, it would be 255. So when we give the value of 255, the LED will glow at maximum brightness, and when we give the value of 0, the LED will glow or LED will not glow. Okay, so let's see whether this code works. So on starting the simulation, yes, the LED is glowing for 1 second and then it gets off for another 1 second. Okay, so our code is running. Now what we want, we want to increase and decrease the brightness of the LED. And in this condition, the LED is working in the digital way itself by just operating at maximum voltage to not operating at all. Yes, because we have given maximum and minimum value. So what if I give the value of 127? So when I give the value of 127, as 127 is half of 255, the LED must glow at half of its value. So the maximum voltage which LED gets is 2 volt on giving the value of 255. When we give the value of 255, Arduino supplies 5 volt, and because of the resistor that we have added, LED gets its maximum voltage, that is 2 volt. So when we write here 127 being half of 255, approximately half of 255, the Arduino will supply half of the voltage, that is Arduino will supply only 2.5 volt, and because of the resistor that we have added here, the LED will glow at only 1 volt. Yes, so let's see whether the brightness of the LED changes. So on starting the simulation, yep, the brightness of the LED has been changed. Yeah, it is not easily visible, so we will add a voltmeter here. On adding a voltmeter, we must get the value of voltage to be around 1 volt. connecting the negative terminal of the voltmeter to negative of the LED, that is to cathode of the LED, and on connecting the positive of the voltmeter to the anode of the LED, that is the positive of the LED. Yes, I have connected the voltmeter in parallel because we get the value of voltage when we connect the voltmeter in parallel. I'm changing the color of the wire. After starting the simulation, yes, we have got here 1 volt. Yes, so Arduino supplies 2.5 volt and LED gets 1 volt just for 1 second. As we have added a delay here, the Arduino will glow at 1 volt for 1 second and then it will off for 1 second. So now instead of 0, if I add say around 50, let's say around 50. So on giving the value of 50, what voltage would Arduino supply to LED and at what volt would LED glow? So we could easily find it out. It's a simple mathematics. Okay, so on clearing this again, so I will clear this backspace. Okay, so what we want, I have given the value of 50, so we want its corresponding voltage value. We want its corresponding voltage value. So it's very simple to find out its corresponding voltage value. Okay, so we know that when we give the value of 255, we get the voltage of 5 volt. Then what would be the voltage when we give the value of 50? So we will just cross multiply it. On cross multiplying it, 5 volt with 50 and 255 with the variable, we give the variable as x, we would be able to find the value of this x. So let's see how we find the value of this x. Okay, so the value of the x would be, x is equal to, or writing it more specific, 255 multiplied by, or 255 into x is equal to, what we get, 255 into x is equal to, on cross multiplying we get 50 into 5. The dot which I have added here, it represents multiplication. Okay, yeah, so this is what we get, and then on bringing this 255 to the denominator, we would be able to find the value of x as x is equal to 50 into 5 divided by 255. So what is the value we get? So on calculating it on the calculator, we get the value as, just a second, we get the value as 50 into 5 divided by 255. We get the value of 0.98. So x would be 0.98. And what does this x means? X means the voltage. Okay, so the voltage would be 0.98 volts. So Arduino would supply 0.98 volt, and as we have added a resistor, the LED would glow corresponding to 0.98 volt. So means as when Arduino supplies 5 volt, LED glows at approximately half of 5 volt, that is at 2 volts. So when Arduino will supply 0.98 volt, LED would approximately work at 0.4 volt. So let's see whether it is working at 0.5 or 0.4 volt on giving the value of 50. So I'm starting the simulation. And yes, it's 0.4 volts. As you can see, 404 millivolt, that means 0.4 volt. So it is around 390 millivolt to 408 millivolt. Yes, so this is how the LED works. This is how the brightness of the LED decreases on giving the values in the analog write function, and on connecting the LED to any of the PWM pin, on the Arduino board, that is pin number 11, 10, 9, 6, 5 or 3. So you can see that the brightness of the LED is also decreasing. So this was for today's video. Thank you for watching.